Welcome to this edition of Science Pill Live. We are so happy to have you back. My name is Darrell Duane. I'm your host, and I am here today with Mary Hiller, who is our in-house science expert. We're going to be digging into some cool science in a second. But before we do, I just want to remind all of our viewers, those of you who are joining us via Zoom, you're able to drop any of your questions as we go in our Q&A spot at the bottom of your screen. And then for those who are watching via Facebook, you're able to just drop your comments or questions in the comment section, and we will be sure to get to them. Any questions we do not cover this season or this episode, we would definitely make sure that we answer those in the following episode and or via our comment section on Facebook, on our Facebook page, all right? And if you're not following us on Facebook, please follow us on Facebook. But before we jump in, so Mary is going to be explaining to us today some cool ways to create the bubble. Some of us may be familiar. I mean, most of us should be familiar. As kids, we've all had the opportunity to play with our bubble wands and create cool bubble experiments. But we're going to learn how to make a stronger, better bubble today. So to no further ado, I'm going to pass the baton over to our in-house science expert, Mary Hiller.
All right, thank you, Darrell. Good morning, everyone. I hope you're having a good Tuesday. Today, we are going to be learning about the science of bubbles. So we're going to go over a little presentation first, and then we're going to be doing some experiments with some bubble mix that I've already made ahead of time. So I'm going to share my screen. And we're going to start with our slideshow all about the science of soap bubbles. There we are. Okay, so first thing we need to ask ourselves is when we're working with soap bubbles is why do we even bother working, or why do we even bother making soap bubbles? Why is it so interesting to see? And one of the reasons is that they're very beautiful, they're very light, and they give us a lot of joy just watching them float around. So we're going to be talking a little bit about the science behind what a bubble is, and also the properties of water and why bubbles are actually able to form. So I'm going to allow my slides to forward here. My computer is thinking for a moment here. I might have to redo this. Let me stop my sharing. Let me reshare my screen. Let's go back here. There we go. So what we have are sort of our science behind our soap bubbles. So what are soap bubbles in the first place? So a soap bubble is a thin film of soapy water that's filled with air. That thin film is actually made of 3 layers. We have a thin layer of water that's sandwiched between
Mary,
2 layers.
I'm sorry to interrupt
of soap.
you, but
go ahead.
the presentation is not showing.
It's not showing?
Nope.
Okay, so it's on mine. Let me stop sharing. Let me go back to our share screen. Is it up there now?
Nope, not on my
Nope.
screen. No.
Okay, so let me go ahead and let me stop my slideshow. Let me restart it. Okay.
And as we wait,
And
got it?
let's go share screen one more time. And let's go to the beginning.
Okay, perfect.
Can you see it now? Okay, perfect.
Yeah.
All right, so let's talk a little bit about what a soap bubble is. So I'm gonna move my face over to the side here that you can't see, so I'm able to see this a little bit better. There we go. So a soap bubble is a thin film of soapy water that is filled with air. We're the ones who put the air into that because we use a bubble wand or a straw to blow those bubbles. That thin film that we see when we create a soap bubble is actually made of 3 separate layers. We have a layer of water that's sandwiched between 2 layers of soap, and that's what our soap bubble is. The film that makes up our soap bubble is only a few hundredths of the diameter of a human hair in thickness. So think about one single hair that's on top of your head, how thin that hair is. You have to divide that hair by 100. So split it in half 100 times. That's how thin that layer of the bubble is that's floating through the air. So soap bubbles are a very, very thin layer of material that are actually very beautiful and can catch sunlight and make some beautiful patterns. So we're going to learn more about how our soap bubbles are actually able to do this. And to do that, we have to understand a little bit about the water that's one of the main components in making our soap bubbles. So when you think about water, many of us think about water we get from the tap, maybe rain that falls from the sky. Have you ever noticed a single droplet of water sitting on a leaf, or maybe on your coat, or perhaps on the surface of your car, or maybe running down the surface of a window? Have you ever noticed what shape it's in? If you look at the picture that I have here of a few water droplets on my rain jacket, you can see that the shape is curved on the top. It's flat on the bottom where it's sitting on the surface, but on the top it's curved. The reason it has this curved surface is because the water molecules inside of that droplet of water are very strongly bound together. And the ones on the surface are pulled inwards towards the drop. And so that gives the drop a circular surface on the top. So it's almost spherical, not perfectly in this example, but it gives you that curvature on that surface. So water behaves as though it's covered with an elastic skin. And we call that elastic skin the surface tension of the water. And this surface tension is very important when it comes to making bubbles, whether it be bubbles in water, like you would blow in through straw into your whatever drink you're drinking, you would make bubbles that way. But it also plays a factor when we make soap bubbles as well. So why do we need to add soap to make bubbles? I'm sure that many of you have taken a straw and blown into maybe your milk or your water or soda pop and made bubbles. Do those bubbles last very long? Normally they don't. They float up through the material and they pop as soon as they get to the surface. So the surface tension in water is really, really strong. And so it pulls the bubbles apart. So bubbles in just using water don't last that long. So that surface tension, we need to lower it. And to do so, adding soap into water lowers the surface tension of the water. And that allows that surface tension to be a little bit more elastic. So when I talked about surface tension with just a droplet of water, thinking of that as an elastic band that's a really tight one that's hard to pull. It doesn't like being stretched very much. It always goes back to its original state. Think of when we add soap to water, that's more of an elastic band that's a little more pliable. It stretches a little more easily, and it takes a longer time to go back into its original shape. So adding soap lowers the surface tension, so it's a little more elastic. And that allows the bubbles to last for a longer period of time. So if we want to make some really good soap bubbles, soap is one of the critical components that we need to be adding into our mix to make those bubbles that are going to be very elastic and are going to be able to last. Now you might be asking, when you've blown bubbles before, have you seen other people blowing bubbles, why are the bubbles round? No matter what shape a bubble has when you first blow it, whether it's one of those long tubular ones that they blow or that they create with those really big bubble wands, or whether it's a small one with the bubble wand you might hold in your hand, that bubble is going to try to form into a spherical shape, into a ball shape, when you give it enough time to get into that shape. It naturally wants to go into that shape. When we blow a bubble, we're putting air inside of it, and it uses the surface tension of that soapy water mix to keep the air inside. So in the diagram we have here, the black arrows on the outside of the circle, that's air pressure from the outside of our bubble. The purple arrows on the inside are air pressure on the inside of our bubble. The blue circle is our water. The red circles are our soap. And the green arrows is that surface tension, that sort of elasticity of that skin of that soap bubble. So the bubble naturally wants to form into a round shape because of the way that water and gas sort of affect the shape of things and how they naturally want to go into that shape itself. Now, when you blow bubbles, you might notice that sometimes you can see these beautiful swirling, colorful patterns on the surface of the bubble. So in a soap bubble, we have the water and the soap that are mixing together, and the soap is sort of protecting the water by sandwiching it. But we have that material that's swirling around in a thin layer as the bubble floats through the air or sits on a surface. So you can see how this material is swirling around by observing the changing patterns on the surface of the bubble. The reason you see those colors and swirling patterns is because of how light is interacting with the surface of your bubble. If you've ever heard of something called a prism is a kind of material that's going to refract light. It's going to break it up, or it's going to diffract light. It's going to break it up into its component colors. So tiny water droplets in the air do the same thing, and that's why we're able to see a rainbow. What you're seeing here is the bubble is causing light from outside to break apart into its component colors, and you can see those colors showing up on the surface of the bubble. So the bubble is acting like a prism, the same way that little droplets of water in our atmosphere act that create rainbows. Now the patterns, the swirling patterns that we see on the surface of these soap bubbles are actually very similar to what we see in weather systems here on our Earth, and also in some of the gas giants in our solar system. So like the clouds of Jupiter and the clouds of Saturn, we can see some of the same swirling patterns in their atmosphere that we see on the surface of this bubble. And some scientists, some physicists actually study bubbles specifically for those reasons, to understand how things move and to understand how currents move through the atmosphere of our planet and of others too. So bubbles are not just something beautiful to look at. We can actually learn a lot about science by observing them too. Now, you probably, if you've blown bubbles before, you notice that they don't last very long and they do pop. The stronger your bubble solution, the longer the bubble's going to last, so it won't pop as quickly. The weaker your bubble solution, it's going to pop more quickly. And the reason that it pops is because even though we have that layer of water that's sandwiched in between the two layers of soap, that water is going to try to evaporate. And evaporate basically means to go from a liquid to a gas. So it's trying to escape from that soap bubble and go into the atmosphere. Eventually, the water is going to evaporate, and that causes the bubble to pop. And if you've blown some bubbles before and you've gotten close to the bubble and the bubble pops and you get a little splashback in your face, which I've had that happen before too, that's basically the bubble skin collapsing on itself as the water is escaping to the atmosphere. And so you're actually getting a little bit of that soap film that splashes back onto your face or maybe onto your hand, depending upon what's closest to the bubble when it pops. But bubbles will also pop if they touch dry surfaces. So bubbles really like moist air. They like moist, wet surfaces. So if you want to try to catch a bubble, which we're going to go over a little bit later, making your hand wet will help you to be able to hold a bubble in your hand. So we're going to be using some of this knowledge. Oops, oh, I went too far. Using some of this knowledge to go ahead and create some different bubble mixes. And we're going to be doing some experiments with these bubble mixes here in our session today, but I also want you to try to make these different bubble mixes. I'm going to show you how to make a bubble wand as well from home. And then I want you to do some experiments too with these and see what you can create. So we're going to start out with our simple bubble mix. This is a very basic bubble mix that most everybody can go ahead and make because all it takes is dish soap and water. So the mix that I found to be some of the best ratios are 3 teaspoons of dish soap and 1 cup of water. You can put that into a glass jar or a plastic container. You mix it up very gently. You don't want to make a lot of bubbles when you're mixing it up. Just mix it up very gently and it's ready to use. Now, most people who really, really like blowing bubbles, they'll say to let this sit overnight because the longer you let your bubble mix sit for a couple hours or even overnight, the better the bubble mix is going to work. So this is a bubble mix that you can make at home. Now, I used my specific dish detergent, and you can see on there, it cleans twice as much better. If you have any sort of ultra dish soap, what you're going to need to do is maybe not add as much because the more powerful the dish soap, you don't need quite as much in your bubble mix. So you can actually tweak some of these measurements. It's not going to hurt you to try a little bit more soap or a little bit less just to see how the bubbles work with this mix. But unfortunately, with this mix, just with the dish soap and the water, the bubbles don't tend to last all that long and they do pop very easily. So to try a better bubble solution, what you can do is along with your 3 teaspoons of dish soap and your 1 cup of water, you can add 1.5 teaspoons of either glycerin or clear corn syrup. You want to gently mix that, and this mix you do have to let sit for about 24 hours because you want that glycerin or that clear corn syrup to really mix into your bubble mix. The reason that we add the glycerin or the clear corn syrup is because it's going to help to strengthen the bubble and it's going to help to hold on to the water more tightly. So as I said before, that water wants to escape. It wants to evaporate. If you can hold on to it a little bit tighter, you can make a bubble that's going to be a little bit stronger and it's going to last a little bit longer. So this is why we add the glycerin or the clear corn syrup to it. Now, one thing I do want to mention is that it does not matter what kind of dish soap you use. You can use any kind of brand of dish soap. It doesn't have to be a powerful one. It can be a generic one. It doesn't have to be a name brand. Just try whatever dish soap you have at home. Try it with this experiment and see how it goes. So one thing I want to do for you today is we're going to be making a couple different examples of bubble wands before we start experimenting with the bubble mixes that I have with me today. And I'm going to show you how to do this. But before we do that, I want to go over some of the materials that I found in my home that you might have at your home that you can use to create these bubbles. So I'm going to show you how to make a bubble wand from some wire. I'm going to be using twist ties from bread loaf sacks. You can use straws. You can use a metal band from a canning jar if you happen to have that around too. You can use the plastic top of a spice shaker, and you can also use a plastic water bottle as well. So I'm going to show you how to create some bubble wands using these materials. And once we're done learning how to make our bubble wand, we're going to try some different experiments. We're going to try to see if we can actually catch a bubble. So normally, when you're running around trying to catch bubbles, as soon as you catch it, it pops. That's because our hands are very dry, but also we have oil and dirt on our hands that can affect the surface of the bubble too. So if we want to be able to hold on to a bubble, as I said before, you can wet your hands because bubbles like wet surfaces, or you can actually use some different types of clothing to help catch that bubble too, because maybe sometime in the past you've gone out and blown bubbles. Maybe a bubble has come to rest on your shoulder or maybe on your sleeve and it stayed there for a little bit before it popped. We can actually do some experiments with that today as well. So let's go ahead and start our experiments for today. So what I want to do is we're going to go ahead and start showing you how to do some of these things, but I also want to encourage you to share your experiments with us. So your experiences of doing this at home, take pictures and share those with us on your social media accounts. You can do that and hashtag us at NMOA at home or hashtag NMOA Science Pill, or you can use both because I would absolutely love to see you doing these experiments with your families at home. So let's go ahead and I'm going to stop sharing my screen here, bring myself up. So what I'm going to do is I'm going to show you first how to make some bubble wands using some materials that you might have around your house. So the first thing I'm going to do is I'm going to take a plastic lid, there we go, of a little spice shaker. So you can see all the little holes in that plastic lid right there. What I'm going to do to make this into a bubble wand is I'm going to take one of the twist ties from a bread bag. I'm going to go in through one hole from behind, and I'm going to take that and I'm going to loop it through another hole. So I'm catching part of that plastic with the tie. So you can see the tie right there inside of some of the holes of the plastic. And then you're simply going to twist the tie to make a handle. And right there, you have a little bubble wand that has multiple little holes. Let's see, there we go. That's a little bit better of a better angle. So that is one way you can make a simple bubble wand if you don't happen to have one at home. Another way you can make a bubble wand is by, again, using twist ties, but this time we're going to use 3 of them. And we're going to make a bubble wand that has a fairly good sized circle that will blow some fairly good sized bubbles. So the first thing you want to do is you're going to take your 3 twist ties here. You're going to take and match them up at the same side, at the same place on each side, and at each end. You're going to twist them together about maybe 3 or 4 times, like that. So then you're going to have something that looks like a little foot. So 3 prongs coming out from that foot. What you're going to do is you're going to choose one of those. I'm going to choose this one over here to be my handle. I'm going to take that and I'm going to bend it down like this so that we're making a very large letter Y out of it. And so this bottom part is going to be my handle. To make the circular area for your bubble wand, you're going to take the top of the two ends here that are loose, and you're going to twist those together as well. So 1, 2, 3, 4, and 5. And then you're going to start separating those two and make it into a circle. And there you have a very basic bubble wand that you can make out of twist ties that you get off of your bread sacks. So we have one here, one example of a bubble wand. We have another one here with our shaker from our spice container. You can also use straws so that these don't go in the trash and don't go into the environment, because straws, as we know, are washable. They are able to be cleaned, so you can use these multiple times to make your bubbles. But also, we can use a water bottle. Now notice I've taken the cap off the water bottle. You can use a water bottle in two different ways, and you have to decide which way you want to use it. You can take the water bottle and, with adult supervision, cut off the bottom part, because that's where you're going to put your bubble solution, and then you can blow through the drinking end, and that will help you to make a bubble wand as well. Or you can leave the whole thing as it is, dip this end into your bubble solution, and then squeeze the air out of the bottle to blow the bubble. And we'll do an example of that a little bit later on. So again, you can use twist ties. You can use the plastic shaker parts from our spice containers. You can use straws. You can use a water bottle. And since I do a lot of canning myself, you can actually use the metal band from a can like this that you would use for canning. You can actually use this because it makes a perfect surface to blow bubbles with. So there's a lot of things you can use around your house to be able to blow bubbles. So here I have in my hands, I have my basic bubble mix. So this is just soap and water. And I have another can that looks suspiciously the same, but this one is a little bit more full. This one has the glycerin inside of it. So what we want to do is, I've already poured out some of the glycerin bubble mix. What I'm going to do is, I have it in my little container here. You can see it right there. I'm going to show you different ways of utilizing these bubble wands to be able to create these bubbles. And I would definitely encourage you to put down a towel. If you're doing this anywhere near your computer, like I am right now, I'm going to put down a towel just to make sure I don't accidentally spill something on the computer. But also, you know, if you're allowed to go outside with your family, go out onto your porch, maybe onto a balcony, depending upon where you live, and have some fun blowing bubbles. So let's use the water bottle first and try our experiment. So I'm going to dip the drinking in, get a good layer of our bubble mix on there. And I'm going to go ahead and compress or squeeze the bottle. Can you see the bubble begin to form? There's our bubble. So this is one really great way of being able to look at a bubble and really notice the colors that you see on the surface. Although I think in this video, you're not able to see as many colors as I can in real life. Eventually that bubble is going to pop because, as we know, the water is trying to evaporate. But this is a really good way of being able to take a look at a bubble up close, and you don't have to worry about it trying to float away from you, as long as you're doing it inside. Because if you're doing this outside, the wind is probably going to cause the bubble to fly away. But this is a really good way of being able to look at a bubble up close. But notice what happens. I've squished the bottle. If I let the bottle go, notice that the air from the bubble goes back into the bottle. So you can actually do this back and forth and have a little bit of fun with your breathing bubble there using your water bottle. So that's one way of using a water bottle to actually make your bubbles. With our bubble wand that has all the little holes in it, with this one, I'm going to dip it into my solution. This one, of course, since the holes are small, the bubbles are going to be small. This one's going to create a lot of small bubbles. Let's see if I can get this to show up on the screen here. So you have a lot of small bubbles that are going to be appearing. And you could actually see, well, they do get caught inside here, but I don't think you can, well, you can kind of see the bubbles that are caught inside too. But of course, you know, these bubbles are going to burst as the water is evaporating. But this is another way of being able to make those bubbles in your home. Now, my favorite one, the one that I found tends to work really well, is the one that we made out of 3 twist ties. So let's go ahead and put that in our bubble mix. And let's see if you, yep, there you can see the solution on the surface. So let's go ahead and blow our bubble with this. Whoop, oh, that popped right off the bat, which does happen. So we don't give up when our science experiments don't work the way we want them to. We always try again. Yep. So there we go. Whoop, and I try to catch it. And of course it pops. So, but since my bubble wand has some bubble mixture on it, it's a wet surface, so I can capture that bubble and actually hold on to it and observe it as well. Now, if I touch the bubble with my dry hands, it's going to pop because that's part of what happens to a bubble when it comes in contact with a dry surface. But what if I take some of the bubble solution and put it on my fingers and then touch the bubble? Look at that. So there are ways that you can actually interact with the bubbles as long as you have a wet surface, like on the surface of your hands. There's also another challenge that I have for you. We talked about at the very end of the presentation, we talked about how sometimes bubbles can come to rest on your shoulder if you're wearing a fluffy shirt, or maybe come to rest on your knee, on your jeans. Let's try and see if we can actually catch a bubble using a glove. Now, this is a simple cotton glove that I have that I use in the winter time. So what I'm going to try to do, we'll see how skillful I am here. I'm going to try to go ahead and blow a bubble and also catch it on my hand using this glove. So let's see how this works. So again, if it doesn't work the first time, we try again. Whoop, there we go. And you see, I have the bubble on the hand. It's rolling around. Let's see if I can put it on the back of the hand too. Oh, and it even went down onto the cloth that's covering the computer right now too. So let's do another one. So gotta go ahead and re-soap myself here. No, okay. Okay, apparently I need a little more practice in blowing bubbles too. So this gives you an idea of some of the different things that you can use in creating your bubbles at home. So not only the mixtures that you can use to create them, but also some different things you can use to create the bubble wands. One thing I want to go over though is with the straws. These, I don't want you to be putting in the bubble mix and then tilting it up, because then what that means is the bubble mix will go down the straw and into your mouth. That is not a good thing. Straws should always be used to blow down, never sideways and never up. So I want to show you one thing that you can try at home. I'm going to be very careful so I don't spill this. I've put some of my bubble mix into a little plastic lid that I have off a yogurt container. I'm going to tap and swirl my straw in the bubble mix and then go ahead and blow. Oop. And you can see, oop, this is another way of making bubbles that you can actually observe while they're sitting on the surface of some bubble mix. So again, using straws, you want to make sure that you're blowing downwards, never out and never up, because you do not want the soap and the glycerin solution going into your mouth, okay? So that gives you an idea of how you can build a better bubble at home. Instead of just using soap and water, add some glycerin or add some clear corn syrup, because that'll help to strengthen the surface of the bubble, and it will help to make your bubbles last longer too. So let's go ahead, have Daryl come back, see if we have any questions from our audience that I'd be happy to answer to the best of my ability. So what'd you think, Mr. Daryl?
I think it's kind of cool. I mean, it's funny because I think growing up as a kid, you don't realize how much science is involved in the and correlating with bubbles and the making of bubbles. So to hear that part was very interesting, especially that part about the color. We had one question in reference to the colors about the bubbles coming from one of our home viewers, and they wanted to know, why are some bubbles very clear as opposed to some bubbles are very colorful? What is the difference, or which causes that difference, if you know?
It doesn't necessarily depend upon the bubble mixture. It depends upon how bright the sunlight is outside. If it's a really bright sunny day, you're going to see some really colorful bubbles. If it's sort of an overcast day, the bubbles are not going to be as clear and as bright and as colorful. But also, some of the pictures you might see online of bubbles, they have those really intense colors. Those are taken in situations where they have certain lights directed at the bubble and they have a dark background, so that the bubble colors can really show up well. So you wouldn't necessarily see something quite that intense out in nature, but the brighter the sunshine you have, the more light's going to be interacting with the surface of the bubble, making it look more colorful too.
Okay. All right, cool. And viewers, I just do want to remind you that you are more than able to, if you have questions, please insert those questions if you're watching via Zoom in our Q&A section. And if you are watching via Facebook Live, you can drop your questions in the comment section and we will answer them while we're live on air. Any questions we don't get to, we'll make sure to get back to you on those. All right. I do have another question from a home viewer. One of their questions, and I don't know if you can answer this question because I know I don't know the answer. But what is the
I'll try my best.
Do you know what is the biggest bubble ever made? Would you know who made the biggest bubble ever? Or
for soap bubbles, well for any bubble that I don't know. The biggest bubble ever made, trying to measure it, I think might be a difficult thing since the bubbles don't last very long. But I have seen images of bubbles where they have those really big bubble wands where they have two sticks and they have a string in between, and then they let the air go through. They don't actually blow into that. They actually let the air go through it. And these can stretch for quite a few meters. So there are some very, very large bubbles. I don't know if Guinness World Record has a record for the largest bubble.
Maybe we can, for our viewer who had that question, maybe we can, do a quick Guinness Book search.
Yeah, let me see if I can find
a record that there's one that's to be broken, that book would have it recorded. You do have a comment while you are researching, however, that question. We have a comment from one of our home viewers. Lauren says, this is not a question, but a comment. I think that this is fantastic. They want to just thank you for doing this so much.
Thank you. Thank you so much.
So we're happy to be entertaining families, and we're happy that the families are loving it. So yes, continue to research that question.
So I just found one of the world records here. So on October 9th of 2005, John Irk of Extreme Bubbles blew the Guinness World Record largest free-floating soap bubble.
Wow.
And this is amazing. It was 105.4 cubic feet, meaning 2.98 cubic meters. So you're talking about something that is extremely long. So yes, there is a world record for blowing a soap bubble, and it's 105.4 cubic feet. And that's in volume, because cubic feet is not just in length, that's length, width, and height. So not quite sure how long that would be, but that is a fairly large bubble. So the largest one is very, very big.
Well, you have another question coming in from our Facebook viewers who are watching via live. One of those questions, the viewer wants to know, is it possible to make bubbles in the rain?
You could, but if a raindrop is going to interact with that bubble, it will cause it to burst, because even though that surface tension is quite strong, having something hit it is going to cause it to pop. So you will be able to blow bubbles in the rain. It's just they won't last very long, because you're going to have those little raindrops attacking the surface. So it is going to end up popping it. So it is possible to do it. It's just you're not going to have as much fun as if it were a sunny day.
Makes sense. We have another question from one of our Zoom viewers. This question that they want to know is there a difference in the recipe if you add soap before water? Does it matter the order in which you add those elements?
No, it doesn't matter. You can add the soap first and then the water. The proportions that I gave you are just something for you to start out with. If you want to try a little bit more soap or a little bit more glycerin, especially if you have like the really intense dish soaps like the ultras, you need to add more glycerin, because that soap is going to affect how long the bubble lasts and how well the bubble forms. So the stronger your dish soap, the more glycerin or more clear corn syrup you're going to need to add. So I'm going to kind of leave it up to you to experiment. And if you find an even better bubble solution, like we said at the end of the presentation, we have those 2 hashtags. Share not only your pictures with us, share your experiences with us, because we would love to hear about that. But also, it allows us to share more information with our senior staff at the museum so that they can see how cool the stuff that we're doing here is as well. So your feedback helps us to make better programming.
Yes, we can stress that. You all, the viewers at home, you all make this happen. So we do need your input, and your input is definitely warranted and desired. So with that being said, we have another question from Bob. Bob wants to know, can you make a bubble inside another bubble?
Yes, you absolutely can. I'm going to try to do that for you right now. No guarantees, because I'm still, even though I've been blowing bubbles since I was a kid, like Mr. Darrell says he was doing when he was a kid too. Sometimes, I do I blow a little too hard and the bubbles blow up or things like that. So I'm going to use my tray of bubble soap again and my straw.
All right.
So you can blow 1 bubble large. Just sit in the tray if it'll stay there. There we go. And you can then re-wet your straw, put it inside of that bubble, and then blow a second one. So you need to make sure that your straw is, you submerge it into it rather than just the tip, because if any part of that dry straw touches the surface of the bubble, it will pop that bubble. But you can get your entire straw wet with the bubble solution. Once you have that bigger bubble blown, put it gently inside of that, blow a separate one or blow a second one, try a third one, try a fourth one, fifth one. See how many bubbles you can get inside of that original bubble. But yeah, it is possible to do that.
Okay. I do want to remind everyone who's watching from home as well that this is just one component of our mini series that we have happening online via live. We do have our first virtual book club Q&A happening tomorrow. So I do want to remind our viewers, definitely, if you enjoyed this, tune in tomorrow. We'll have Dr. Sue Black, OBE. She'll be in and she'll be talking to us about her book, Saving Bletchley Park. And I'll talk a little bit more about that at the end when we do our promo. But I just want to remind you, viewers that are watching, before we get too late in the program, that we do have multiple programs happening throughout this week, as well as Art Face Off. Talk about that later at the end. But we have another question. The other question, this will probably be I'm thinking our last question before we start to roll out. So this question comes from a Facebook viewer, and they want to know, ultimately, why are bubbles always round? Why do they typically come out round? You may have answered this already earlier, but
a little bit, yeah. So in physics, we understand that a lot of material, if given an opportunity to take any shape, say out in space, where you don't have to worry about fitting into a container, or you don't have to worry about conforming to any sort of say gravity that you would experience here on the Earth, everything wants to form into a spherical shape because it's the simplest shape for any material to form into. So when you talk about the idea of a model of an atom, it's always shown as a circle. Mm-hmm. When you see bubbles, they're shown as circles. When you think about planets, they're normally spherical. Some of them might be a little bit oblate, because when you talk about the gas giants, Saturn and Jupiter are just ever so slightly, squished. They're not perfect spheres because they're swirling around and their gases are swirling around too, giving them a little bit of oblateness, meaning they're more, not really egg-shaped, but they're just a little bit off of being perfect circles or perfect spheres. But it's a natural shape. It's the shape that is most easy for materials, whether it be gas or liquid or maybe solids in space to form into.
Well, I was going to interject and say, like, fruit, vegetables, most of those things, I mean, when we think about natural things we eat, they start off spherical as well. The organic products we grow in our backyards. Think about a lot of the seeds that you might have planted in your garden if you're gardening this year. A lot of them are very small and very round. So with bubbles, since it's a gas and some liquid that's forming there, the natural position for it to be in, or the most easiest shape for it to form into, is a circle, is a sphere. So that's why it forms into a sphere. You can force it to take different shapes if you have certain bubble wands. Like if you build something that looks like a cube, that's a 3-dimensional cube,
And there's my cat. If you get three-dimensional cubes, you can actually create a square bubble inside of that. But bubbles are naturally going to form into a round shape, into a sphere, because that's the most easiest, not position, but the most easiest shape for it to take on. And there's one of our astro cats. So everybody say hello to Susie. So
everybody wants their 15 minutes.
Yeah, there you go. That's what it is.
Well, we thank you so much for giving us the science behind bubbles. Bob commented and chimed in, said they're going to try the bubble inside the bubble. So thank you.
Awesome.
With that being said, I do want to remind or encourage all of our viewers to tune into all of our many assorted programming and programs that we have available via our Facebook, our website, and our Zoom. So if you're ever looking for something to do, Noma at Home, we have it for you. So tomorrow, tune in. We have sit down Q&A again with author, and actually she's a advocate for women in tech. So that's another really cool thing about this speaker that'll be with us tomorrow, and author that'll be with us tomorrow. But Dr. Sue Black, OBE, she's going to be talking about her book, Saving Bletchley Park. And we're going to also later this week have story time. I believe we're doing a story time live this Saturday. And in case you missed me earlier, because Art Face Off is sort of like my baby, so I definitely want all of those artists who are watching, this is your opportunity to win $75. We encourage you to jump into the $75 challenge called the Art Face Off, where we select a work of art and we ask our viewing audience to create a work that is inspired by that piece. So this week's work is sort of hearkening to what's currently happening with the recent pandemic. So we do encourage you all to, create work. The artist we selected, his name is Joel Lopez. The piece that we have that we're using is titled Pestilence. Yeah, Joel's one of we love him.
I love his work. Yeah.
The piece is titled Pestilence. However, we do not own the piece, so we just want to make that clear that that is not a piece that we own by the museum, in case anyone of our viewers want to purchase it. But we do want to again ask that you use this piece as a point of inspiration, and that can be found on our Facebook page. So make sure you're following us on Facebook, make sure you're following us on Instagram, and then anytime we have a live or an event coming up, we will post on those sites accordingly. All right. Our website before we close out is www.newarkmuseumart.org. So make sure you log in and check us out. Again, thank you, Mary Hiller, for this awesome Science Pill Live.
Yay!
Always love kicking it with you. And again, I'm your host, Darryl Dwayne, and we will see you later on this week. You all have a great day. Take it easy.
All right, bye, everybody.
Bye.